Coming to the classifications of adverse drug reactions, this is very important and I will be explaining about all these in a detail in the next slide. Okay. So type A is augmented reactions, B for bizarre reactions, and C for continuous drug usage, and D for delayed reactions, E for end of the dose, and F for failure of therapy. We are going to expand and see. And this is very much important because you should know that where does this pharmacovigilance play a major role in this classification. So type A reaction means this we can expect and this happen in normal doses. Okay. And the adverse effect what we are going to get is mild and manageable. Say for example, cetirizine. Cetirizine can cause sedation. Instead of cetirizine, we can keep as H1 antihistaminics like diphenhydramine. It has a potential to cause sedation. So once we know that this drug can cause sedation, but if we have a cold, we preferably used to take cetirizine because it is going to relieve our stress a lot rather than causing sedation. So these type of adverse effects are called type A adverse effects. Okay. When it comes to type B adverse effects, mainly drug allergies fall into this type B categories. Okay. What does this mean means that it is not expected for all individuals at the normal doses, but if it happens unexpectedly or it is uncommon, but if it happens, it is going to cause a high mortality. We call this as type B adverse drug reaction. The best example for type B adverse reaction is hypersensitivity reaction caused by penicillin. Okay. Say for example, this, if you have a little bit knowledge about this area under the curve concentration in pharmacology, it is well and good. But I'll just try to explain in simple terms. Okay. So once you take a drug where it reaches the maximum and then it will get eliminated. Okay. So in this time frame, from the time you took the drug to it reaches peak until it is getting eliminated into the body. This we call it as a bell-shaped curve. And any adverse event that happened during this, we call it as type B. Okay. And if, for example, with penicillin, if there is hypersensitivity reaction, it is going to be life-threatening and it has to be reverted back at the earliest. So this type of reactions are called type 2 adverse, type B, that is drug allergies. Okay. Next, coming to type C, this happens due to the chronic effect of drugs because of prolonged use of the drugs. One example is like analgesic nephropathy with aspirin. Okay, if you take aspirin for the long time, because of its increased bioavailability, it can cause analgesic nephropathy. Similarly, there are a lot of oncology trials that is happening. So in those oncology trials, you will be giving drugs in different cycles. Okay. So if you move from cycle 1 to cycle 2 to cycle 3, what happens is there will be accumulation of this drug and there will be increase in bioavailability of this drug so that it can cause chronic effects. Okay. Next is coming to type D, that is delayed effects. Best example for type D adverse drug reaction is teratogenic effects that are commonly caused by drugs that are given during pregnancy. The whole concept of pharmacovigilance came from this thalidomide, which causes phecomalia. So because of that only, this pharmacovigilance has evolved. But you should not say this as the answer when you are asked in interviews. So which type of reactions in which pharmacovigilance play a major role is type F, which we are going to discuss at the last. Okay. So type D, from where this whole pharmacovigilance has started, and type D is due to delayed effects. Okay. Not only teratogenic drugs like steroids, which has been given for a long time, can lead to osteoporosis. Like all these drugs, which has been taken for a long